Question 4. This question is about hydrogen and compounds of hydrogen. Figure 3 shows the display formulae for the reaction between hydrogen and chlorine. So that's a display formulae for hydrogen gas and chlorine gas. And that gives you 2HCl. And the situation on the left hand side, which is the reactant, you are always breaking the bond. You have to break that, you have to break that. And when you break bond, that's endothermic, because you have to put energy to break that. That's endothermic. And when you make bond, that's exothermic. So this will be plus value, that'll be a plus value because you're breaking it, and this will be a minus value. So you got these values here, so that would be that, but it would be plus. So we could do that actually, so that would be plus 436 because it's endothermic. Endothermic is plus. The next one would be plus as well because we're breaking that, so that would be plus. But the forming of bond is negative, so that would be minus. But you got two of them, so that would be 2 times that, and it would be minus. So we could do that. So that's what's going on there. So with question 4.1, and which expression shows how the calculated or how to calculate the overall energy change for the reaction in figure 3. So for the reaction, we know that we've written earlier, so we are breaking bond for hydrogen, so that's hydrogen there. We're breaking it, so that's a plus. We're breaking the chlorine bond, and we're taking away the forming of bond. So basically, we've already done it. So that would be the right answer. So question 4.2. The reaction between hydrogen and chlorine is exothermic. Explain why this reaction releases energy to the surrounding. Exothermic is releasing energy to the surrounding. Energy is needed to break bond. That's endothermic. And then the next one is energy is released when bond forms. So that's exothermic. So the product is exothermic and the reactants are endothermic. Also, exothermic is greater than endothermic, and therefore energy release is greater than the energy needed. Third question is question 4.3, and we've been given this diagram here. Figure 4 shows part of a reaction profile. So it's showing the reaction profile of this diagram here. So it's a reaction profile diagram for the reaction between hydrogen and chlorine. Complete the reaction profile in figure 4. You should label the activation energy, label the overall energy change. So we need to complete this. This is the reactant. So we need to take that all the way to the product there. So the product should be there. So if we do that, this is what we're going to get. We take that reactant to the product, and that's the product. Because the overall is negative, that means it's below the reactant. So reactant is 0, and the product will be the difference. It will be negative. So that's, and then the overall, so that will be the overall energy change. And the activation energy is always measured from the reactant, and so this is what we should get. So we could actually add the values for the reactant. So if we bring in the graph, so that was if we give in the data here, so you can see that one is 436 and this is 346. So that would be reactant. And if we multiply that by that, so this would be bigger than that one. So let's add this together and then take away that from it. So this is what we're going to get. We're going to get the 436 plus 346. And that would be 2, 1. That would be 8. And that will be 1 carried 4, well that will be 7, so that's plus 7, 8, 2. But we also have this one here forming the bond here, so we have 8, 6, 4 here, that's negative. So the overall will be the 8, 6, 4 plus 7, 8, 2, and the difference between them will give us the value that we need. So we can see that that would be 2. 1 goes to there, that will be 8. So the difference is minus 82. And that value here will be minus 82. Question 4.4. Draw a dot and cross diagram for a molecule of hydrogen chloride, HCl. Show the outer shell electrons only. Well, so we are looking to draw this one here. Hydrogen with 1 electron in the outer shell. Chlorine is in group 7. So it's got 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. So 1 electron from chlorine and 1 from hydrogen form a bond, and that bond is structure of dot and cross diagram for HCl. Question 4.5. Figure 5 represents molecules of methane and of polyethylene. That's methane and that's polyethylene. As a polymer, methane is a gas at room temperature, but polyethylene is a solid at room temperature. Explain why the methane and polyethylene exist in different states at room temperature. Alright, so that's due to their structure. And methane is smaller, as you can see, compared to polyethylene, smaller molecule, and so has a weaker intermolecular, such as van der Waals forces. The intermolecular forces need less energy to overcome. Therefore, the boiling point and the melting point are lower for methane. Methane, with the E here, methane is also a gas at room temperature. Polyethylene has much larger molecules, so it's got more mass, has stronger intermolecular forces because it's got more mass, and therefore there'll be more intermolecular forces, so they all add up. More energy is then required to break the structure of polyethylene. The melting and boiling point will be higher because the mass is higher. Polyethylene is a solid also, that helps.